So, good morning, guys. The last class we were discussing on problems on dynamics. Okay, single bodies when they are inclined or when they are not inclined, all these things we are studying. Now, what happens if body is connected with another body with a pulley system or any other systems? Okay, so here we are going to study about the motion of connected bodies. So what happens, see, if you are having two objects in two separate inclined planes, how will you calculate if you see this, they are connected with a single string. Okay, so for both of them they are having same tension, right? So if A is having a higher or more weight, then practically this A slides down to this side and B will follow them. B will go up, right? Okay, so if mass of A is greater than mass of B, A moves forward. So you just need to draw separate free body diagrams of this. Okay, and again, for any dynamics problem, this point is very important. Force in the direction of motion is taken as positive and force opposite to a direction of motion is taken as negative. This is the sign convention that you need to use, right? Okay, now we'll go for the first problem. A mass of 60 kg lies on a smooth horizontal table. It is connected to a fine string passing over a smooth guide pulley on edge of a table to a mass of 50 kg hanging freely. Find tension in the string and acceleration of the system. Okay, so here a 60 kg mass is lying on this table and it is just connected to another mass through a string which is having a mass of 50 kg. Okay, this is connected through a pulley, right? So you need to find out the tension in this string and at what acceleration this will move. Okay, right. So from this diagram we assume that this 50 there is no chance that this will move along this side or this side. I mean this will move this side. This will not take until there is no force along this direction. This will not move, right? But here 50 kg is applied towards this direction, so there is a tendency of this object to move along right side. So we assume that acceleration is going to happen in this thing, in this direction, in downward direction. Then A will follow the same and go in this direction. So the given data are mass of A is given, weight of A is, from that we could find out weight of A, mass of B is given, weight can be found out. You need to find out the tension, what is the acceleration. See, another important thing, since there is only one system of pulley, or if this is directly connected, if I am pulling this in 1 meter per second square, or the B is moving in 1 meter per second square, then A will also move in 1 meter per second square. If B is moving in 5 meter per second square, A will also move in 5 meter per second square. So here acceleration of A and acceleration of B will be same. So you draw the free body diagrams of both things. So for A, there is a tension. Here the friction is neglected because there is no, I think the question they have given smooth pulleys on smooth, on a smooth horizontal table. Smooth means there is no friction, right? As a reaction 60 kg and there is tension. And free body of B is, you have 500 Newton here and a tension. Okay, so there is acceleration. This body have a tendency to move along this side. So its total force, net force is T. Of course Rn is equal to 60 kg, that there is no need to find that. Okay, so here in y direction the net force is this is moving along this direction, so 500 minus 2. And here in x direction it is t, which is equal to ma into a. And here it is equal to mb into a. T is equal to ma into a. 500 minus t is equal to mb into a. T is equal to 60a. And you give this value in this equation. 500 minus 60a equal to 50a. 110a equal to 500. Acceleration is equal to 4.54. From there you could find out tension. Okay, so it's a simple problem. You just need to draw the free body diagrams and analyze in which direction each body moves. Okay, we'll do another problem. Two blocks are joined by an inextensible string shown. If the system is released from rest, determine velocity of block after it has moved 2 meter. Assume coefficient of friction between block and plane is 0.25. Pulley is weightless and frictionless. Okay, so this is the diagram. You have a pulley here, somewhat similar to last problem, but what you need to find here is that you have a 300 kilo, so this have a tendency to move along this side, so 200 kg will move towards right. And what you need to find out, determine velocity of the block after it has moved 2 meter. Okay, so what happens if it moves 2 meter, and in what velocity this will move? Not acceleration, velocity. But in order to find out velocity, you need to find the acceleration of either B or A. Both will be same, right? They are connected directly through just one pulley. Okay, so the given data are written. Okay, velocity of block V has to be find out. Again the same procedure, free body diagram of A and B. For A, you have a 200 kg, so 2000 Newton weight. You have a reaction, you will be having a tension here and a friction in its opposite direction, right? 0.25 Rn. Okay, similarly for B, 3000 Newton and a tension, that's all. Okay, now the total force, net force will be for A, T minus 0.25 Rn, whereas here since acceleration is along this direction, 3000 minus T, which will be equal to ma respectively. Okay, again since no motion in y direction, Rn is equal to 2000 Newton. See, Rn is equal to 2000 Newton. Substitute this, and here also no force in x direction. Net force in y direction is 3000 minus t, which will be equal to ma into a and mb into a. Okay, you will equate these two equations. You know ma and mb. Only thing you need to know is tension and acceleration. You have two unknowns here and two equations, right? If you equate this, you will get acceleration is equal to 5 meter per second square. Okay, similarly you can also find out the tension in that. Now using laws of motion, you know acceleration, distance in which A is moving is 2 meter. We have to find out V. A, S and V, we have this equation, V square is equal to U square plus 2AS. V is equal to 4.47 meter per second. Okay, now we'll do one more problem which is very interesting. Okay, this is the system of bodies shown in figure starts from rest. Determine acceleration of body B and tension in string supporting body A. See, so apart from the other two problems, there is a small difference here. This is getting more interesting because here you are having two pulleys. Okay, and this A will have the effect of two pulleys, such that if A is moving downwards, the B will have the effect of two pulleys here. Okay, so for your I think you might I need to recollect the physics chapters that you have studied from +2. For a system of n number of pulleys, say A is a block which is causing the motion initially. See, from this diagram, this is, we are applying force here. Then YA be its displacement. So this is moving YA. It moves a body B. Together with that, it is followed by a body B. Okay, which passes through n number of pulleys. Here we have 2 pulleys. If there is n number of pulleys, then displacement of B, YB is given by YB is equal to 1 by 2 raised to n minus 1 into YA. Okay, so for this case, how many number of pulleys? If there is only one pulley, see, first of all we will see that if there is only one number of pulley, what will do? YA will be equal to YB, right? As we have done in other problems. That means 1 by 2 raised to 1 minus 1 is 0. 1 by 2 raised to 0 is 1. So YB equal to YA. But here we have 2 pulleys. 2 raised to 2 minus 1. So 1 by 2 into YA. So this YB will displace half that of YA. If YA is moving 5 mm, this will move only 2 mm. Okay, that is the use of pulley. Okay, right? So here say SA is displacement of A and SB the displacement of B. SB is equal to 1 by 2 raised to 2 minus 1 into SA. Since here there are 2 pulleys, SB is equal to 1 by 2 SA. Okay. Now, similarly, it's the case of acceleration also, same thing. AB is equal to 1 by 2 AA, AA is equal to 2AB. Now, no other confusions now. You need to find out the free body diagram of A. Here also you have one more thing. See, for A it's okay, 500 Newton downwards and there is one tension, name it as T, right? Okay. Now, if you analyze the free body diagram of B, the B is like this here, but you have a string connected. Okay, if you analyze this, you will be having tension T going upwards and downwards. From here again tension T and again tension T. So if you know the free body diagram of this pulley, there will be a tension T along this direction, tension T along this direction, and tension, unknown tension along this direction, like this. See, for diagram of this pulley, there will be a tension T and tension T. In order to make it in equilibrium, you should have a tension of 2T here. Okay, here you have T and T, add it such that you will be having 2T. So this tension will be from B, it is producing 2T here. Okay, I hope you understand the concept. So then you draw this diagram, 2T, rest all same, similar method. There will be a inclined 750 Newton load. Here you are neglecting friction since this is not given. So motion in x direction will write the acceleration is along this direction. So 2T minus 700 750 sin 30 is equal to MBAB, and 2T minus 375 equal to 75AB. Now you will do just mathematics, then you will get the term. Okay, these are all simple mathematics. Okay, you will get the values of acceleration of B and acceleration of A. Okay, and tension also you can find out. Okay, so with this I am stopping this lecture. If you have any doubt, please ask me or ring me. Subscribe this channel. Okay, thank you.